Questions 1 through 10 on the 2010 grade 12 AMC 12A. What is the value of this expression? Well, there's a couple of ways, of course, of doing this. The first way is just to do it the way it's in the brackets, but then the other way is to try to see if anything cancels. Either way probably wouldn't take that much time. So let's proceed. So if we just immediately just take it out of the brackets, right, it'll be 20 minus 2010 plus 2001, and then this one is 2010 minus 2001 plus 20. The good news is this cancels with that, and that cancels with this. So all you're left with is 20 plus 20, and that is, of course, 40. So number 1, the answer is C. A ferry boat shuttles tourists to an island every hour starting at 10 a.m. until its last trip, which starts at 3 p.m. One day the boat captain notes that on the 10 a.m. trip there are 100 tourists on a ferry boat, and that on each successive trip the number of tourists was 1 fewer than on the previous trip. How many tourists did the ferry take on the island that day? So at 10 a.m., 11 a.m., 12, 1 p.m., 2 p.m., and then finally at 3 p.m. Those are the times that the ferry is taking people to the island. And the island might be Newfoundland, because you have to take a ferry from, I think, Nova Scotia, perhaps, to go to Newfoundland. Anyhow, so at 10 a.m., let's say the question tells us it's 100 tourists. And then every hour after, it's 1 less. So 99 at 11, 98 at 12, 97 at 1 p.m., 96, and then 95. And they're asking us basically to add up these guys. And that's going to be 600 minus, let's see here, 15, I believe, because every hour it's 1 less. And that is 585. So number 2, the answer is A. Rectangle ABCD pictured below shares 50% of its area with square EFGH. Square EFGH shares 20% of its area with rectangle ABCD. What is AB over AD? All right, well, they have told me that this is half. This is half of the total. So I'll just call this X, and therefore this will be X also, right? They're equal. They're 50-50. And then they're telling me that this is 20% of that total square. So I'll just write that in there. So it's 20%. And to make things easy, I'll just call it 20 instead of a percentage. The area is 20. So that means X is equal to 20. And we have to somehow figure this out that it all matches, right? So very quickly, if I let AD equal to 2 and then this length here equal to 10, that would make that equal to 20, correct? And then therefore this has got to be 10 and that's got to be 2, I should say. So AB over AD is going to be, let's see, AB is 20 and then AD is 2, and that is 10. But before we circle the answer and move on, we have to ensure that this actually works, right? I could call these 20 and 1 instead of 10 and 2. So let's say if it actually does work. If that is a square, that's 10, that's 10. So therefore, if this was 2, then that means the area is 2 times 10, which is 20, which is what I labeled. But if this is 10 and this is 10 and this is a square, EFGH, then this has got to be 10. And then the total area of the square has to be 100. And therefore, the parts that are not shaded have to add up to 80. And they do, because the shaded part is 20. And 100 minus 20 is indeed 80. So those numbers work out. So I just wanted to double check. So therefore, number 3 is E. If x is less than 0, then which of the following must be positive? Well, what I always like to do is just use a number. It makes it much less abstract. So I'll just use -3, right? It's less than 0. And let's go through these answer choices one at a time using my x being -3. All right, so this is -3 over the absolute value of -3, which is 3, and that's -1. That's negative. Negative, be careful here, -3 squared. That's -9. So that's negative also. How about this one? -2 to the x. So again, be careful. It's 2 to the -3. So this is -1 over 2 to the 3. And that is -1 over 8. So far everything's negative. The next one, D. -3 to the -1. That's -1 over -3 to the power of 1. So this actually becomes just 1/3. There we go. We have a positive. And let's just finish this out here. This is going to be the cube root of -3, and that is approximately -1.4. So the only positive one is this guy, so therefore this is the answer for number 4, D. Halfway through a 100-shot archery tournament, Chelsea leads by 50 points. For each shot, a bullseye scores 10 points, with other possible scores being 8, 4, 2, and 0. Chelsea always scores at least 4 points on each shot. If Chelsea's next N shots are bullseyes, she will be guaranteed a victory. What is the minimum value for N? So let's see, we have her closest opponent has X points so far after we are halfway through this tournament. And Chelsea, they tell me, is 50 points ahead. So her score is X plus 50. Now, let's say, extreme case scenario, because we have to guarantee it, right? That her opponent scores a bullseye for every single shot that remains. Now, it's a 100-shot tournament. We're halfway through, so there's 50 shots to go. And for those 50 shots, the opponent scores bullseyes. So that score will be 50 times 10. So the total score of the opponent, male or female, is X plus 500. And for Chelsea to win, she has to have at least, 1 point more, I guess, right? Or she's got to be greater, let's just say that. So that means that whatever she scores here, if you add it up, has got to be greater than this. So let's concentrate on now, what is she going to score there, right? Well, she's going to score a certain number of bullseyes, and they tell you that, for N shots, and for each she'll get 10 points. And then the other shots, if she scores N bullseyes, and there's 50 shots to go, 50 minus N is the other shots that are not bullseyes. And for those, she will get at least 4 points. They tell you that in the question. So we multiply that by 4. So this is what we have to show. That this plus this has got to be greater than that. So if you put all that into equation, it is as follows. X plus 500, which is the opponent, has to have a score that's less than Chelsea's score, which will be what she had in the beginning. She had X plus 50, and then adding this part, 10N plus 50 minus N times 4. All right, good news is the X's cancel, so we can get rid of that. Bringing this over, we get 450. And then expanding that, we'll get 200 minus 4N. And then let's see here, this becomes 6N is 250. And therefore, N is greater than 250 over 6. And what is that in terms of a number? About 41.6? Yeah. So for Chelsea to win, N has to be greater than 41.6. And N is obviously an integer. So the minimum possible value for N is 42. So number 5, the answer is C. A palindrome, such as 83438, is a number that remains the same when its digits are reversed. The numbers x and x plus 32 are 3-digit and 4-digit palindromes respectively. What is the sum of the digits of x? So x is 3 digits and x plus 32 is 4 digits. So that immediately tells me that x is sufficiently close to 1,000, right? Because as soon as you add 32, it becomes a 4-digit number. So I'm just going to play around with numbers close to 1,000. I'm going to try 999 first. Why not, right? Because that's a palindrome. I'm choosing palindromes, right? Because both of these, x and x plus 32, are palindromes. So if this is x, what is x plus 32? Well, it is 1031. And is that a palindrome? No. Okay, no problem. My next palindrome would be 989. If I add 32, I get 1021. That's not a palindrome. Oh, this x is getting confusing here. I won't use x. I'm putting x there to kind of denote that that's wrong, but there's an x up here, so that's getting confusing. So forget that. We'll just put a dash there. That's no good. The next one, 979, which was Ben Johnson's time when he won the Olympics in 1988, but we all know what happened afterwards. And this added to 32 would be 1011, and that is also not a palindrome. All right, don't get discouraged. How about 969? That, when you add 32, becomes 1001, and there you go. You got 2 palindromes. So this is indeed going to be our x. Now they want the sum of the digits of x. So that means we want 9 plus 6 plus 9, which is 24. So number 6, the answer is E. Logan is constructing a scaled model of his town. The city's water tower stands 40 meters high, and the top portion is a sphere that holds 100,000 liters of water. Logan's miniature water tower holds 0.1 liters. How tall in meters should Logan make his tower? All right. So, not that you necessarily need to know this, but the volume of a sphere is 4/3 pi r cubed. If you're in grade 12, you probably already know that. So we have to compare the volume of the actual sphere to his model. So I'm just going to denote big R and little r. And the good news is when you compare those, everything cancels except the r's. And this, they have given you actual values. They've told you that the sphere is 100,000 and his model is 0.1. So this ratio of big R cubed over small r cubed is 1 million. And if you take the cube root of both sides, you get big R over little r is 100 over 1. So that is the ratio. Because remember, you can't compare 100,000 to 0.1 because those are volumes. We want a comparison that involves a linear distance, such as the height or the radius. And that's why this has to be done this way. So our linear comparison is 100 to 1. So that means that his tower, in his miniature model, I guess, has got to be in the same ratio. So it's a 40 in real life, and we'll say his tower in his model is t, and that ratio has got to be the same as the radius of the spheres. So solving for this, you get 100t is 40, and therefore t is 40 over 100, which is 0.4. So number 7, the answer is C. Triangle ABCD has AB equal to 2 times AC. Let D and E be on AB and BC respectively, such that angle BAE is equal to angle ACD. Let F be the intersection of the segments AE and CD, and suppose that CFE is equilateral. What is ACB? All right, so let's draw a diagram. I don't know what this triangle looks like, but let's just draw a big one because I think we're going to have to label a lot here. So whatever, right? And probably not the most drawn to scale diagram, but that's okay. So this will be A, this will be B, and this is C. And they're telling me that AB is 2 times AC. So if this is X, this is 2X, something like that. And then now we've got to draw D somewhere. I'm not sure where, but let's just say here. And then E has to go somewhere. Let's just say here. And then we are connecting the line segments AE and CD. So let's do that. A to E and C to D. And then they're telling me that CFE is equilateral, where F is the intersection point right there. Okay, not bad. Not horrendously terribly drawn not to scale, if you know what I mean. All right, so since this is equilateral, these are going to be 60 degrees, right? All these angles. 60, 60, 60, like that. And then they told me one more thing, this one right here, that BAE, I'll call it theta, is equivalent to ACD. And so that's theta. Okay, so they want what? ACB? So they want this angle. So essentially what it boils down to is find 60 plus theta, which is angle ACB. Okay, let's work with this. This is really just filling in, one of those things like you fill in the blanks with angles. So for example, let me just move this F here. That's kind of annoying. This opposite angle's got to be 60, right? This angle is going to be 120, since the sum of the angles about a line is 120. This angle, it's an opposite angle, it'll be 120. And like that, we're just filling stuff in. That's all we can do at this point. If you look at this triangle right here, that means this angle is going to be 60 minus theta. And anything else, if I keep going, I think this is going to be, this angle in here will be 120 minus theta. And then therefore this angle in here, 60 plus theta, not that you really even needed that one. And then if you look at these angles, this angle actually is 60, since it's 60 minus theta plus theta. And then this angle is 60 plus theta, and therefore this angle has got to be 60 minus theta, because the sum of the angles have to add up to 180. Yeah. So that's about as far as we can go with the angles, right? We've exhausted this whole triangle. But one thing I noticed is that these sides give us a very important clue. You've got a triangle now that has 60, 60 plus theta, and 60 minus theta. And then we know for a fact, if you remember, that if you have any triangle that has the side lengths of a ratio, I should say, of 2, 1, and root 3, then it is a 60, 30, 90 triangle, where this is 30 and this is 60. So this triangle will match up perfectly if theta is equal to 30. Because if theta is equal to 30, this angle would therefore become 30, and this angle would become 90. And it indeed would match those ratios. And that's exactly what it is. So theta is indeed 30. So that means 60 plus theta is equal to 90. So number 8, the answer is C. A solid cube has 3 side lengths, or side lengths of 3 inches. A 2 by 2 inch square hole is cut into the center of each face. The edges of each cut are parallel to the edges of the cube, and each hole goes all the way through to the cube. What is the volume of the cube in inches of the remaining solid? So first and foremost, we've got the volume of the original solid, which will be 3 to the power 3, which is 27. And then the hole that's cut through all sides has a common center, and that common center has a volume of 2 to the power 3, which is 8. So what I'm going to do is just draw one of those common guys. So one block that's cut out of the cube will look like this, approximately. And the common center is a 2 by 2 by 2 block like this that is in the very center. And that one I just calculated as 8. But remember, when we do that, we also have to count these guys, right? Can't forget about those guys. And there's going to be 6 of them. 2, 2, and 2. So we have to figure out the volume of that. So it'll be 6 times the volume of each of these. And each of these, if you label this whole thing was 3 from there to there, and this was 2. So that means each of these from there to there is a half in terms of its length. And then this part and this part are just 2's. Like that. So the volume is a half times 2 times 2. And that looks like 12. So this and this is cut out of the original sphere, cube. So what's left is 27 minus 8 minus 12. And that is equal to 7. So number 9, the answer is 8. The first 4 terms of an arithmetic sequence are p, 9, 3p minus q, and 3p plus q. What is the 2010th term of the sequence? So first term, second term, third term, fourth term, and then dot, 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 all the way until the 2010th term. Well, they've given you this as p, 9, 3p minus q, and 3p plus q. And then this one, we don't know. But they have given us a very important clue, of course, that this is an arithmetic sequence. So arithmetic sequences are of the form a plus d, a plus 2d, a plus 3d, and so on. And the 2010th term would be a plus 2009d. Correct? So we have to work with this. This is basically going to be all algebra here. So first and foremost, in any arithmetic sequence, if you take the second term and subtract from it the first term, you get left with just d. So we're going to do that with those values that they've given us in the question. So that would basically be that d is equal to 9 minus p. All right. So we do the same thing again, but this time using the third and second. If you take the third term and subtract from it the second term, you again get just d. So we're going to do that with these guys. So that would be 3p minus q minus 9, like that. Okay, that's my second. Third is the same thing involving these two guys. If you take the fourth term and subtract from it the third term, third term, minus a minus 2d. This again just gives you d. So we're going to do the same thing with these two guys. So that's going to be 3p plus q minus 3p plus q, right? Because you're minus, two minuses. So this just becomes 2q is equal to d. All right. So now we've got to work with this and try to figure out what is p and what is q. Okay, no problem. This equals that because they're both equal to d. So I'll set that equal to each other. 9 minus p is equal to 3p minus q minus 9. So this becomes 18 is equal to 4p minus q. And therefore q is equal to 4p minus 18. Okay, I think we're getting close. Now the next one, obviously I'm going to set this equal to this since they are both equal to d. So 3p minus q minus 9 is equal to 2q. And that means that 3p minus 9 is equal to 3q. And at this point, we can just substitute, right? Because we've got two equations, two variables. You guys have done this a million times. Substitute for q. You get 3p minus 9 is equal to 12p minus 54. And that means that 45 is equal to 9p, and therefore p is equal to 5. And then if p is 5, we can substitute that in here, and we get q is equal to 20 minus 18, which is 2. So there we go. Q is 2, p is 5. All right. Okay, so we are pretty much on our way to solving this. We have just one final step, which is trying to figure out this guy right here. The 2010 term, which is a plus 2009d. Okay? Well, a is equal to p, and p is equal to 5. So that's 5. And then 2009 times d. And d we can figure out from any of these. I'll just use this one since it's simplest. D is equal to 2q, and q is 2. So d is 4. And there you go. So 2009 times 4 is what? 8,036? Yeah. And therefore, plus 5 will be 8,041. 8041. And therefore, number 10, the answer is A.